Okay, hello again, everybody. Welcome to today's lesson. We're going to talk about section 9.1. We're going to talk about the transformation of reflection. So we're going to talk about reflections, go a little bit deeper than we did earlier in the year when we just touched on them. Remember that when you reflect a figure, you flip it over a line. So a reflection is a flip over a line. There's always a line that you're reflecting it or flipping it over, a line of reflection. Okay? Remember the before shape or figure is called the preimage, and the shape after is called the image. Remember that if you have a point or letter like a vertex B or point B and the preimage, you use the prime symbol in the image, so you would just use the same letter and call it B prime to label it, okay? And again, that's something we've gone over before, just a little review. Also remember a reflection, the preimage and image are exactly the same. It preserves congruence, also known as what we call an isometry. So a reflection is a type of transformation called an isometry because it preserves congruence. So the before and after shape should be exactly same shape and size, exactly congruent, okay? Now we're going to do two main types of reflections, those on a coordinate grid and those not on a coordinate plane or grid, okay? First we'll do some that are not on a coordinate plane. Now some of y'all are good, really good visually. You can picture what something is and what it's going to be afterwards. Some of you can draw well. If you can't, it's no big deal. Do the best you can. Try to be as accurate as you can and to make sure it looks reasonable and looks accurate. Okay? All right, so first three problems here, we're just going to reflect it over the line. Now, if you look at number one, you have a triangle. Now, you have a point on the line, and you have 2 points off the line. What we're going to do is we're going to reflect the 3 points. Because if you can visualize this flipping over the line, it's going to be somewhere down here. Okay? Now, one way you can do this, when you reflect a point, it's like whatever distance it is to the line, and I have a pencil here because I'm going to erase these markings when we're done with number one. You got to remember when you reflect or flip it, whatever distance each point is from the line of reflection, it needs to be the same distance on the other side. So what you can do, if you just lightly in pencil, you can help yourself draw an accurate reflection. So whatever this distance is, draw it the same distance out, and that will be where this point ends up. And that should be the same as that. Those should be congruent segments. Now, look at this. See how it makes a 90-degree angle with the line of reflection? That's important. You don't want to draw it over here. That will not create 90 degrees. All right, for this point over here, if you draw a little helper segment, same distance or length out the other way, that's where this point should be approximately, okay? And you can eyeball these little helper segments. You don't have to actually get a ruler and measure it precisely, okay? Now this third point of the triangle, since it's on the line of reflection, it stays on the line of reflection in the image as well. All right, now that you have your 3 points, you can go ahead and connect them, and you should have, as long as these segments are the same length to and from, on each side of the line, you should have a pretty accurate triangle. And what you can do to clean things up is if you drew the little helper segments, just go ahead and erase them so they don't mess the figure up too much And there you go. All right, number two. Now, number two, this shape lies on the line of reflection. Some shapes and figures do that. Now, to approach a figure like this, you can do it just like we did over here. You can take these 3 points and reflect them separately. That's what we're going to do. But realize, this part is on the left side. It's going to flip to the right. This part of the triangle is on the right side. It's going to flip to the left. Okay? So you just flip each part from each side to the other side, and we still will have a full triangle at the end. So the preimage lies on both sides. The image will do the same. All right, so let's draw some little helper segments. From A, go straight to, and then straight out. So that's where A prime should be. From B, go straight to, straight to, straight out. B prime. And then from C, helper segment here, straight out the other way. And that's where C prime should be. And then once you have your 3 vertices in the image, you may make your triangle. And you should have a pretty accurate reflection. And once I erase the helper segments, we'll be able to see it a little bit better here. And there you go, number 2. And one more, not on a coordinate plane, before we try some of those on the back to finish up. Now, sometimes your line of reflection isn't horizontal like number 1 or vertical like number 2. It's a pain in the butt like number 3. It's diagonal or sideways. Remember, you can always rotate the paper if it helps you. Make the line vertical or horizontal. You can always do that, okay? But same idea. If you're going to draw helper segments, make sure each point is the same distance to and from. All right? Now, remember, you don't go this way, because that would not be a 90-degree angle that hits that. You have to go this way. So if you're reflecting P, P is going to be out here. Because remember, it has to hit at 90 degrees to be perpendicular. So P prime isn't over here somewhere. It's straight to, straight from, about there. Okay? Same thing with F. Little helper segment to and from. About like that will do. And L, I'm going to rotate my paper. That'll help me draw the helper segments. L is going to, it looks about the same. Now this thing could end up looking real weird at the end, but this is a tough one to do, not on a coordinate plane. And then I is the furthest, so I prime should be the furthest away. So a little bit longer, I think. About like that. All right, once you have your 4 vertices in the image, your prime points, you can go ahead and connect them. And actually looks like kind of a 3-dimensional figure. But I'm going to erase the helper segments. And as long as you were careful and you went to and from 90 degrees straight through, and your helper segments, if you drew them, were congruent, that is about what the figure should look like. Okay? Now, before we do some on the back, we need to do a little review. Because on the back, Some of them do not give you the line of reflection if you're looking at number 4 and 5 real quick. Rather, they tell you what line to reflect it over. So you got to remember how to graph lines from algebra. So a quick review. Most lines are horizontal or vertical, some are diagonal. So a quick review down here in the bottom left. If you're going to graph y equals -5, that line, that any time it's y equals a number, no x variable, that is a horizontal line. A line that is x equals a number, like x equals 2, x equals a number with no y variable, that is a vertical line. Now, y equals x. This line is a diagonal line like this. Goes through the origin and cuts through at 45 degrees. Okay? The slope of 1, up 1 over 1. So if we graph each of these, y equals -5. I'm going to make them dotted because when we do our examples on the back, they'll be dotted. Y equals -5 is a horizontal line, goes through -5. So -5, -1, 2, 3 is right here. So it would be a dotted horizontal line. That would be the line y equals -5. The line x equals 2 is a vertical line going through 2. So 1, 2, vertical line. And that would be this line of reflection if we were going to flip the figure. And then the line y equals x, like I mentioned, goes through the origin, slope of 1, up 1 over 1, cutting through at 45 degrees. So, or you go up 3 over 3 to get another point, or just go like this if you want. This would be the line y equals x. Okay, here we go. Let's hop to the back. All right, so number 4, we're going to reflect this shape that's already there over the line y equals 4. So what is this? Is that a horizontal or vertical line? Right, it's a horizontal line. So let's draw this line of reflection first, and then we'll flip the shape over it. Goes to +4. So 1, 2, 3, 4. I will make our line of reflection that we're flipping it over dotted. All right, now you can actually count pretty accurate when you're on the grid. We'll do the same as we did in numbers 1, 2, and 3. We'll do each of these 4 points separately, and then we'll connect, okay? So, point O, you go 2 to get to the line of reflection, so you go 2 out. So there's O prime. Point C, you go 1, 2, 3 to get to the line, so you go 3 out. 1, 2, 3. N is 3 from the line, so 3 out. And then I, 2, 3, 4, 5, 6, 7. 1, 2, 3. Oops. 1, 2, 3, 4, 5, 6. Sorry about that. Just go one more up. I put you off the grid a little bit. And once you have your 4 points, that would be the reflected figure. Okay? And it should look exactly congruent because you can count on the grid for 100% accuracy pretty much. Okay? Number 5. We're going to reflect this triangle over x equals -1. So let's graph this line first. This is a vertical line going through -1. So a straight up and down line through -1, -1, and let's draw it. Now, one of the points is on the line of reflection, so it's going to be on the line of reflection at the end, so we don't even have to do anything with L. So for P, we count 2, 1, 2, 3, 4, 5, and count from 1, 2, 3, 4, 5. There's P prime. And then Z to the line. 1, 2, 3, 4. from the line. 1, 2, 3, 4. And then connect your 3 points, your 3 vertices. And there you go. All right, number 6. Number 6, we're going to do like what we just did to finish up, but they want us to graph the points and get the shape first. Now look at the wording here. Reflected in the line y equals x. Sometimes it doesn't say over the line, it says in the line. All right, it means the same thing. Sometimes they'll use that wording instead of over, okay? It means the same thing. Y equals x, remember, is that reflection line, okay? And then let's graph these points to get our preimage, which is going to be a triangle, 3 points. So 4, 2. For point B. Point D, 3, negative 5. Point F, negative 2, negative 5. All right, so it looks like here is our triangle. All right, let's do each point separately. Now, sometimes it might be hard to count diagonally, but sometimes it's not too bad. Like this is 1 square diagonal to, so 1 square diagonal from. This right here, 1, 2, 3, 4, so 4 from. 1, 2, 3, 4. And then this point, 1 and a half, so 1 and a half out. Be careful when you're counting diagonal. You can also count up and over, but sometimes it's a little tricky, so just be careful. Just make sure that your reflection line is accurate, and however much it takes to, you count exactly from as well. Once you get your 3 prime points, guys, your image should look about like that. And there you have it, reflections in 9.1. Thanks for listening, and I will talk to y'all next time. Bye-bye.